Let's solve this important problem. Investigate the values of lambda and mu such that the system of equations x plus y plus z is equal to 6, x plus 2y plus 3z is equal to 10 and x plus 2y plus lambda z is equal to mu may have A unique solution, B infinite solution and C no solution. See my dear students, this problem and problems like these, that is they may change the numbers or they may change the parameter from lambda mu to ABC so on. These are very important. These are very much important as they have been frequently asked in the VTU examination for 6 to 7 marks. So please pay close attention here. Okay, I request you to get your books, your pen ready and practice along with me. Pay full attention here so that you understand each and every step perfectly and don't lose any marks in the examination. And see, the theory behind solving such type of question is the consistency of a system of linear equations, and that I have already done in the previous video. So, if you haven't watched it yet, then please I request you to go refer the playlist or find the link in the description below. Watch the video first, because without understanding that theoretical concept, you cannot move ahead with these problems. Okay, and if you are new to this channel, then please don't forget to subscribe for further upcoming videos. So let's start with solving this problem here. Now we have the system of equations. The first thing in consistency, what we do, we always write A augment B, the augmented matrix, the first thing. So first I write here. So we have A semicolon B or augment B is equal to, see, 1 1 1 x 1x 1y 1z. So 1 1 1 semicolon 6. Be careful of taking all this here. So 1 2 3 1 2 3 10, then lastly 1 2, see it's lambda z, parameter is lambda z, and this is mu. Okay, so what's the first step here? The everything remains same. We have to follow the same circus. It is by using row transformation, we have to make all this below the principal diagonal element 0. That is, the simple concept is what I showed you. Making use of this one, this one, this one, it make this below this both 1 0, and it is very simple because 1 minus 1 is 0. Okay, so we can simply write. So I do both one together. So I write R2 minus R1 and R3 minus R1. That's it. Okay, so I'm going to make this one and this one 0, making use of row R1. So this will be now 1 1 1 6 as it is. See, 1 minus 1 0, 2 minus 1 1, 3 minus 1 2, 10 minus 6 4. Simple calculations again. So see, R2 minus R1, now R3 minus R1. 1 minus 1 0, 2 minus 1 1. Now here see, there is lambda here, so operation remains the same. So we are operating the whole row by R3 minus R1, correct? So what is that? Lambda minus 1. And lastly, this is mu minus 6. Okay, done. So below this first one towards 0. Now second, the second column, this, which one is that? This one. So making use of this one, it will make only this below that 1 0. Simple. Again 1 1. So very simple question. So R3 minus R2. So we have it here as this as A augment B equals 1 1 1 6 0 1 2 4 as it is 0. Now see, 1 minus this one 0, row R3 minus R2. Now see, be careful here. Lambda minus 1, see, R3 minus R2, right? Lambda minus 1 minus 2. Lambda minus it minus 2. Minus and minus 2 is what? Minus 3. So lambda minus 3. And lastly, what we have? See, mu minus 6 minus 4. Mu minus 6 minus 4. Mu minus 6 minus 4. Minus 6 minus 4 minus 10. So it is what? Mu minus 10. That's all. This is all we have. Okay. So I rewrite here once again. Okay, for a clear understanding. So we have A augment B is equal to the same I will take down here 1 triple 1 6, then 0 1 2 4, and lastly 0 0 lambda minus 3 and mu minus 10, right? This is what I have. Okay. Now coming back to the theory of consistency of a system of linear equation. See, read the question carefully. Investigate the values of lambda and mu. What? Lambda and mu. But find lambda and mu such that a system of equations, which is here, has unique solution. So tell me, what is meaning of unique solution? If you go back to the theory, first thing I write here, A is what? Unique solution. See, the meaning of unique solution is what? Okay, it is, recall, rank of A augment B equals rank of A, that is equal to n. N is the number of variables. Here it is x, y, z, 3 variables. Okay, simple. So when is this possible? See here, as I discussed earlier also, see, only this part is for what? Gives rank of A, correct? But the total whole, this whole matrix will give rank of A augment B. Okay. So now see, unique solution is what? Rank of A augment B is equal to rank of A is equal to n. When is this possible? Watch this carefully, the result here. Okay, what we've done with row transformation, the result, watch it carefully. Now, when is the rank of A augment B is equal to rank of A is equal to n? So, see, when lambda, if lambda is not equal to 3, am I right? See, I am writing it. If lambda is not equal to 3, then only is possible. Why? Tell me, if lambda is not equal to 3, then and mu may be equal to 10 or may not be, independent, doesn't matter. Okay. So, if lambda is not equal to 3, then only the rank of A will be 3. Correct. See, this whole rank. See, if in case if I make lambda equal to 3, whole row becomes 0, so rank will become 2. Are getting the point? So only when lambda is not equal to 3, then all the 3 rows will be there, so the rank becomes 3. Okay. In that case, rank is A is equal to 3. In that case, that implies rank of A augment B equals rank of A equals 3, that is the number of elements, number of variables, sorry, n. So it is consistent and what? Unique solutions. Consistent and unique solution. That's it. Now B, the second case. What is second case now? Infinite solution. Infinite solution. So for infinite solution, what is the condition? That's why go back to theory again, refer it. Okay. The condition for infinite solution is rank of A augment B should be equal to rank of A, and that should be lesser than n. What is n here? 3. So the rank should be lesser. It can be 2 or 1, whatever. When is this possible? Only when lambda is equal to 3 and mu equals to 10. See what happens. If lambda is equal to 3 and mu is equal to 10, observe here, this lambda 3 minus 3 0, 10 minus 10 0, whole row becomes 0. So the rank of A, this green part will be, that implies rank of A will be how much? Tell me. Lambda is equal to 3 minus 3 0, 2. Similarly, rank of A augment B, the whole matrix, 10 minus 10, because I taken lambda is equal to mu is equal to 10, 0. So whole row is 0. So lambda of A is also, so the rank of A is also 2, and the rank of a argument b is also equal to 2 lesser than n, it is 3. That is it. Therefore, you can say consistent and infinite solutions. Okay, what is the condition? If lambda is equal to 3 and mu is equal to 10. The last part, no solution. No solution. So, again, tell me, when does the system has no solution? The theory is in front of you. When rank of A is not equal to rank argument B. That is it. Okay. If rank of A is not equal to rank of A argument B, then it is no solution. That is inconsistent. So, when is that possible? When? Tell me when? When lambda equals 3 and mu not equal to 10. Getting it? When lambda equal to 3 and mu is not equal to 10. In that case, if lambda becomes 3, then what? See, this whole row becomes 0. Rank of this green part is 2. But mu is not equal to 10. So, full row, this is not 0. That is, the full rank of A is 3. Then what? It's possible only when if lambda equals 3 and mu is not equal to 10. Then we say that rank of A equals 2 and rank of A argument B equals what? 3. That is it. Therefore, rank of A is not equal to rank of A argument B. Therefore, what? Inconsistent and no solution. That's it. Getting it? So, clearly from the theory, unique solution means what? Rank should be equal is possible only when lambda is not equal to 3. Understand it? Okay. Then only what? This is consistent and unique solution. Okay. And then infinite solution possible only when lambda is equal to 3 and mu is equal to 10. Then this both 0. Then both rank are same and lesser than n. And no solution means what? Lambda equals 3 and mu is not equal to what? 10. In that case, this rank is only 2, but whole rank is 3. So, the ranks are not equal. So, inconsistent, no solution. So, these are the values of lambda and mu for which the system of solutions for the unique solution, infinite solution or no solution. That is it. See, such type of problems, as I told you, are very important. They may give the same problem in examination, or they may change the numbers, or they may change lambda and mu to A, B, C, alpha, beta, solved. Okay. So, this involve the solution also, along with that the theory is involved. If you do not write the theory properly, then they will not give the marks, they will cut the marks in the examination. So, please do not take it lightly. Okay. If you take it lightly, then obviously you are going to do something wrong in the examination and lose the marks. So, please practice it. Keep on watch the video repeatedly, keep on practicing until you get perfect. So, that is all for today's class. See you in the next video. Bye.